Hi everybody, we are going to be consolidating our knowledge of remainders, and we're going to be working through lots of different types of division questions. And this lesson, or this video, is pretty much a recap, but just before we get into the lesson, just want to show you our problems of the day that I'm going to be posting up every day. Think of these 1, 2, 3 as the chilies. They're going to be random questions, and they are questions based on year 5. You've got to remember that 1, you're not through year 5 yet, and 2, you've missed a bit. So this is optional. This is just for those of you that want an extra bit of a challenge. Some of them you're going to be able to do, some of them we haven't covered yet, but it might be nice for you if you're stuck or you've never come across a type of question. It might be nice for you to look up on your own, but we will be covering these sorts of questions as the week goes, or as the year goes on, not as the week goes on. We can't cover them all in a week. So there you go. I'll post the answers later on in the day. So back to our consolidation of remainders. So here's a little warm-up. Choose one. Over here we have our 2 and 3 chili. Over here we have our 1 chili. You'll notice that the first 4 questions are going to be formal written methods, and our last 4 questions, so 5 to 8, are going to be the basic operations. This one that you see here, number 5, on both of them, that is a division. We will cover that every fraction is just simply division. So give it a go. Pause the video because I'm about to go through the answers. So for this first one, we've got 465, then we've got 2,130, then we've got 2,248, 2,517, well done if you got those, 39, 776, 11,565, 1,777. Up here, 6,144, 19,000, almost 20,000, 788, 39,582, 6,462. If I made any mistakes, please let me know. 7,444, 26,180, 2,065, 981. Now, we are going to be following this sort of format because I think it's quite good. Gives us lots and lots of practice. So pause it, have a look through them, see how well you did, and let me know. So I'm going to recap, but you'll notice this question, we have covered this question before. As I say, we are learning the method. So have a think back to it. How are we going to answer this question? We've got 72 sticks and they're shared equally between 3 children. So here I've lined it up using place value counters. Now you can use coloured pasta to help you. You might use buttons, you could use rice, it's up to you. It doesn't matter too much what you're doing, but I would encourage anybody to use some sort of object that you can. You might even cut out something, but also we can lay it out this way, and you may also see it written out in a more formal method. These two, so over here and over here, is 2 ways of representing the same thing. I quite like this one because it's using pictures, and I quite like using pictures. So our first step, write down the divisor and dividend. We've done that. Can you remember which one's the divisor? Is it this one or is it this one? The divisor is this one. Makes this one the dividend. Okay, so our next step, for step 2, is to take our 7 tens. So over here 7 tens, over here 7 tens, and we are going to divide them into 3. So if we look over here, again, remember we were putting them into groups of 3. We had our 1 left over. So what that looks like is one group of 3, another group of 3. There's 2 groups of 3. So if we go over here, how many 3s go to 7? 3, 6, that's 2. You see our 2 groups. But we've got one set of 10 that's not in there. That's not in there. Because we only got up to 6, didn't we? So what are we going to do? Of course, we're going to exchange that. So that's the 2 groups. We've exchanged that 1 10 for a group of 10. Got 2 there. And that's what we do here. That is one group of 10 exchanged for 10 10s. Yeah, so then we're going to put that in. What are we going to do with this? We're going to share this between the 3 groups as well. So we've got 12 ones over here, because we had the 10 ones and the 2 we already have. If we look, we've got 12 ones over here. So we're going to do, how many does each group get if I split 12 ones into 3 groups? So how many 3s are in 12? We know that because we can do things both ways. How many 3s in 12? 3, 6, 9, 12. That must be 4. Let's see if we're right. How many groups of 3 have we got over here? We've got 4 groups of 3. Yeah, so we've got our 2 groups of 3. And our 1, 2, 3, 4. 24. 2 groups of 10 and 4 ones. How many 3s in 7? 3, 6. That's 2. We've 1 left over because 6, 7. And then 3s into 12 go 4. 72 divided by 3 is 24. Hopefully you understand that. If you're not sure, please feel free to watch it again. Whoops, that should have been hidden. So here are some questions for our 1 chili. We've got some questions down the side here. You can answer them in a second. I want you to use this method. Whoa, stop looking through. Here is a method to solve. So this is the calculation that we're going to do. We're going to do 4,894 divided by 4. So in my thousands, how many thousands have I got? I've got 4,000. So I'm just going to do them as circles. Yeah. Now I've got 8. Ugh, stop. 1, 2, 3, 4, 5, 6, 7, 8. How many 10s have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many 4s? 1, 2, 3, 4. 4 thousands. Ugh. I'm just going to do it at the top. 4 thousands, 800s, 9 10s, 1, 2, 3, 4, 5, 6, 7, 8, 9 10s, and 4 1s. Now I'm going to be looking to group them up into 4s. Yep, divided by 4. How many groups of 4? I'm going to get a different colour pen for this. So here's a group of 4. One group of 4. One group of 4. I've also got another group of 4. So that's 2,000. Sorry, not 2,000, 2 groups. One group, 2 groups of 4. How many groups of 4? One group of 4. 2 groups of 4. Oh, but I've got this 1 left over. So I've got 2 whole groups of 4. What do I do with this 1? Well, I'll take that 1. I'm going to take this 1 10 and swap it for how many 1s? 10 1s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah? So I can cross that out now, because that has gone all the way over there. So how many groups of 4? 1 group of 4, 2 groups of 4, 3 groups of 4. So I've got 3 whole groups of 4. What have I got left over? I've got a remainder of 2. So my answer for this top question will be 1,223 remainder 2. Now that remainder 2 is this bit down here. There's our remainder 2. 2 that didn't fit into a group. So I've got 1 group, 2, 4, 3 groups, and then remainder of 2. What I would like you to do is to use this method to answer these 3 calculations. And I would love to see your working out in this 100 grid. So you might need to draw it a few times. It doesn't have to be really neat. It could just be as simple as that. I'm still using the highlighter. It could be as simple as that. Yeah, well actually we need another one. So it could be thousands, hundreds, tens, ones. Yeah, and then you draw them out. Yeah, like that. So in the first one you're going to do 6, and then 6, and then 1, and you're going to put them into groups of 5. I hope that that's clear. Now, for our next couple of chilies, so this is going to be our 2 and our 3. It's a little bit looking a little bit more into the steps of our question. So a baker bakes 49 cakes in an hour. Their tray holds 49. Sorry, I'm going to start again. Baker bakes 49 cakes in an hour. Their tray holds 4 cakes. How many trays do they need? So you can use a more formal method for this. And now we've got lots of sub questions here I'm going to be wanting you to look at. But first, let's start with our main multiplication. So we've got our divisor, our dividend. Dividend goes inside, divisor goes outside. So how many 4s go into 4? 1. How many 4s go into 9? 4, 8. No, I've got 1 left over. So that's 2, 4, 8, remainder 1. Yeah, another way we can look at that is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're looking at how many groups of 4, because we've got our 4 here. 1 group of 4. 1 group of 4, another group of 4, so that's 2 with 1 left over, remainder of 1, that's remaining outside of a group. So, we know that. How many trays is this person going to need? Have a think about that. If they've got 12 cakes and they've got 1 left over, how many trays are they going to need? They're going to need the 13 trays, aren't they? Because they can't just have that one floating around. It's got to be in a tray. How many of these trays, how many of these 13 trays are going to be full? Well, if we made sure we filled up a tray before we moved on to the next tray, it's going to be 12 full trays. Have a think about why your answers are different. So we know that because this is 12 full groups of 4, and our remainder is the one that didn't or couldn't make a whole group of 4 on its own. So that's why they're different, because this is representing how many full trays, and this is looking at the total of trays regardless of if they are full. Yeah? Okay. So we've got another one here. Muffins are packed into trays of 6 in a family, and in one day a factory makes 5,623 muffins into groups of 6. 5 into 6, can't do that. I like to cross it out, you don't have to. Lots of people are forgetting this. If it doesn't go and we have to move it over, we put a 0. The reason why, if we look at our thousands, hundreds, tens, ones, 1, 2, 3, 4, 5. How many groups of 6? 0 groups of 6. Yeah, so we've got to transfer all of those into there. Now I'm not going to do that because I'll be here forever drawing out 50 of them, but that's why it's a 0, because there are no groups of 6. How many 6s in 56? 6, 12, 18, 24, 30, 36, 42, 48. 48, 54. So that to me looks like 9, and I'm on 54. So that means I need 2 more to get to 56. Now, I know 6 times 4 is 24, so it's got to be 3. 6 times 3 is 18, which leaves 4 left. 6's into 43. Now, I just said that it was 42, so that must be 7. The remainder of 1. You can tell me if I'm wrong. Yeah, 6 times 6 is 36. Add on another, which makes 7 times 6, which is 42. Yeah, remainder 1. Okay, so how many trays are we going to need? We're going to need 938, because we can't have that extra 1 on its own. How many trays are going to be full? 937. And that is because our answers are different, because this one is looking at how many are full, and this one is looking at how many in total, regardless of if they are full. We're going to have 1 tray that's not full. It's only going to have 1 on it. Okay, so 3 and 2 chili. I'm going to provide you with an activity sheet. It's going to be a PDF. I'll upload it separately. Please show me you're working out. It's really important that I see you're working out. Whether you do a formal short division, or whether you do the thousands, hundreds, and ones place value, either doesn't matter. And I've also got some extension activities for you. I'll show you in a sec. Eventually, as a game, answer those 3 questions. If you want to have a go at some of the questions on the activity sheet, you definitely can have a go at them as well. There's lots on there that you can do. So here's an extension. If you've finished the PDF sheet, have a look at this. For this calculation, can you write a number story where I round the remainder up? Have a think about when we did the bakery with the trays. How many trays do you need? And then once you've done that, can you write a different story where you would round the remainder down? So that's when we were looking at our full trays. So can you come up with your own one? And can you write a number story where you just have to find the remainder? Yeah, so it might be how many cakes are not or can't make it onto a tray. Well done. We've also got a question here as well. These 2, I'll obviously provide these for you in a PDF for you in the morning. Can you spot the mistake that's been made? And we've got a thing here. We've got a calculator. Jackie is calculating that, and it's a bit more of a reasoning. Help you guys to go a bit deeper into it. So, you've been very good, and this is something that this will be a whole unit that you've done.